Hello everyone, welcome back to the Backend Masterclass. In this lecture, we're gonna learn how to securely store users' password in the database. As you already know, we should never store naked password. So the idea is to hash it first and only store that hash value. Basically, the password will be hashed using Bcrypt hashing function to produce a hash value. Beside the input password, Bcrypt requires a cost parameter, which will decide the number of key expansion rounds or iterations of the algorithm. Bcrypt also generates a random sort to be used in those iterations, which will help protect against the rainbow table attack. And because of this random sort, the algorithm will give you a completely different output hash value, even if the same input password is provided. The cost and sort will also be added to the hash to produce a final hash string, which looks something like this. In this hash string, there are 4 components. The first part is the hash algorithm identifier. This 2a is the identifier of the Bcrypt algorithm. The second part is the cost. In this case, the cost is 10, which means there will be 2 to the power of 10 or 1024 rounds of key expansion. The third part is a sort of length 16 bytes or 128 bits. It is encoded using base64 format, which will generate a string of 22 characters. Finally, the last part is the 24-byte hash value, encoded as 31 characters. All of these 4 parts are concatenated together into a single hash string, and it is the string that we will store in the database. So that's the process of hashing users' password. But when users log in, how can we verify that the password that they entered is correct or not? Well, first we have to find the hash password stored in the database by username. Then we use the cost and sort of that hash password as the argument to hash the password users just entered with Bcrypt. The output of this will be another hash value. Then all we have to do is to compare these 2 hash values. If they are the same, then the password is correct. Alright, now let's see how to implement these logics in Golang. In the previous lecture, we have generated the code to create a new user in the database. And hash password is one of the input parameters of this create user function. Also, in this create random user function of the unit test, we are using a simple secret string for the hash password field, which doesn't reflect the real correct values this field should hold. So today we're gonna update it to use a real hash string. First, let's create a new file, password.go, inside the util package. In this file, I'm going to define a new function, hash password. It will take a password string as input, and will return a string or an error. This function will compute the Bcrypt hash string of the input password. In this function, we call Bcrypt.generateFromPassword. It requires 2 input parameters, the password of type byteslice, and the cost. So we have to convert the input password string to byteslice. For the cost, I will use the Bcrypt.default cost value, which is 10. The output of this function will be the hash password and an error. If the error is not nil, then we just return an empty hash string and wrap the error with a message saying failed to hash password. Otherwise, we convert the hash password byteslice to string and return it with a nil error. Next, we will write another function to check if a password is correct or not. This function will take 2 input arguments, a password to check and the hash password to compare. It will return an error as output. Basically, this check password function will check if the input password is correct when comparing to the provided hash password or not. And the standard Bcrypt package has already implemented this feature. All we have to do is to call bcrypt.compareHash and password function and pass in the hash password and naked password after converting them from string to byteslices. And that's it, we're done. Now let's write some unit tests to make sure these 2 functions work as expected. I'm going to create a new file, passwordtest.go, inside the util package. Then let's define function test password with a testing.t object as input. First, we generate a new password as a random string of 6 characters. Then we get the hash password by calling the hash password function with the generated password. We require no errors to be returned. And the hash password string should be not empty. Next, we go check password function with the password and the hash password parameters. As this is the same password we used to create the hash password, this function should return no errors, which means correct password. Let's also test the case where an incorrect password is provided. I will generate a new random wrong password string and code check password again with this wrong password argument. This time we expect an error to be returned, since the provided password is incorrect. To be exact, we will use a require.equal_error function to compare the output error. It must be equal to the bcrypt.error mismatch hash and password error. Okay, the test is now completed. Let's run it. It passed. Awesome. So the hash password function is working properly. Let's go back to the user test.go file and use it in the create random user function. Here I'm going to create a new hash password value by calling util.hashPassword function with a random string of 6 characters. Require no errors. Then change this secret constant to hash password instead. Alright, let's run the whole DB package test. All passed. Now if we open the database in Table Plus and check the users table, we can see that the hash password column is now containing the correct Bcrypt hash string. It looks just like the example I showed you in the beginning of this video. One thing we want to make sure is, if the same password is hashed twice, 2 different hash values should be produced. So let's go back to the test password function. I'm going to change this variable's name to hashPassword1. Then let's duplicate this hash password code block and change this variable's name to hashPassword2. What we expect to see is the value of this hashPassword2 should be different from the value of hashPassword1. So here I used require.notEqual to check this condition. Okay, let's rerun the test. It passed. Excellent. But to really understand why it passed, we have to open the implementation of this bcrypt.generateFromPassword function. As you can see here, in this new FromPassword function, a random sort value is generated, and it is used in the Bcrypt function to generate the hash. So now you know, because of this random sort, the generated hash value will be different every time. Next step, I'm going to use a hash function that we've written to implement the create user API for Simplebank. Let's create a new file, user.go, inside the API package. This API will be very much alike the create account API that we've implemented before. So I'm just going to copy it from the account.go file. Then let's change this struct to create user request. The first parameter is username. It is a required field, and let's say we don't allow it to contain any kind of special characters. So here I'm going to use the alphanum tag, which is already provided by the validator package. It basically means that this field should contain ASCII alphanumeric characters only. The second field is password. It is also required. And normally we don't want the password to be too short because it will be very easy to hack. So here let's use the min tag to say that the length of the password should be at least 6 characters. Okay, the third field is full name of the user. There's no specific requirements for this field except that it should be required. Then the last field is email, which is very important because it will be the main communication channel between the users and our system. we can use the email tag provided by the validator package to make sure that the value of this field is a correct email address. There are many other useful built-in tags that were already implemented by the validator package. You can check them out in its documentation or GitHub page. Now let's go back to the code to complete this createUser function. Here we use the context.shootByJSON function to bind the input parameters from the context into the request object. If any of the parameters are invalid, we just return bad request status to the client. Otherwise, we will use them to build the db.createUserParams object. There are 4 fields that needs to be set: username, hash password, full name, and email. So first, I'm going to compute the hash password by calling util.hashPassword function and pass in the input request.password value. If this function returns a not nil error, then we just return a status internal server error to the client. Else, we will build the createUserParams object, where username is request.username, hash password is the computed hash password, full name is request.fullname, and email is request.email. Then we call server.store.createUser with this input argument. It will return the created user object or an error. Just like in the createAccount API, if the error is not nil, then there are some possible scenarios. Keep in mind that in the users table, we have 2 unique constraints. One is for the primary key username, and the other is for the email column. We don't have a for-range key in this table, so here we can remove the for-range key violation codename from this case, and leave the unique violation codename here to return status forbidden in case a user with the same username or email already exists. Finally, if no errors occur, we just return status OK with the created user to the client. Okay, so now the createUser API handler is completed. The last step we must do is to register a root for it in the server.go file. Here in this new server function, I'm going to add a new root with method post. Its path should be /users, and its handler function is server.createUser. And that's it, we're done. Let's open the terminal and run make server to start the server. I'm going to use Postman to test the new API. Let's select method post, fill in the URL, http:/localhost port 8080/users. For the request body, let's choose raw and select JSON format. The first field is username. I'm going to use Guang1. The second field is full name. I'm going to put my name here. The next field is email, guang@email.com. And finally, the most important field, password. Let's say secret. Okay, let's send this request. It's successful. We've got the created user object here with all the correct field values. Let's open the database to find this user. Here it is. So our API is working well in the happy case. Now let's see what happens if I send this same request a second time. We've got a 403 forbidden status code. And the reason is because the unique constraint for username is violated. We're trying to create another user with the same username, so clearly it should not be allowed. Now let's try changing this username to Guang2, but keep the email value the same, and send the request again. We still got 403 forbidden, but this time the error is because the email unique constraint is violated, exactly what we expected. If I change this email to guang2@email.com, then the request will be successful since this email doesn't belong to any other users. Okay, now let's try an invalid username, such as Guang number 2. This time the status code is 400 bad request, and the reason is the field validation for username failed on the alphanum tag. There's a character hash in the username, which is not alphanumeric. Next, let's try an invalid email. I'm going to change this username to Guang3 and this email to guang3email.com without the character. We've got 400 bad request status again, and the error is field validation for email failed on the email tag, which is exactly what we want. Okay, now let's fix this email address. and change the password to a very short value, such as 123, then send the request one more time. This time we've got an error because the password field validation failed on the min tag. It doesn't satisfy the minimum length of 6 characters condition. Before we finish, there's one more thing I want to tell you. Let's fix this password and send the request again. Now it's successful, but you can notice that the hash password value is also returned, which doesn't seem right because the client will never need to use this value for anything, and it might raise some security concerns as this piece of sensitive information is being transmitted in the public. It would be better to remove this field from the response body. To do that, I'm going to declare a new struct in the user.go file, create user response struct. And it will contain most of the fields of the db.user struct, except for the hash password field that should be removed. Then here, at the end of this createUserHandler function, we build a new createUserResponse object, where username is user.username, full name is user.fullname, email is user.email, password changed is user.passwordchanged, and createdAt is user.createdAt. Finally, we return the response object instead of user. And we're done. Let's restart the server. Then go back to Postman, update the username and email to different values, and send the request. It's successful. And now there's no hash password field in the response body anymore. Perfect. So that brings us to the end of this lecture. I hope you have learned something useful. Thank you for watching and see you in the next lecture.